This video is for task 2.6. How do you solve a system of equations by substitution? And we will answer this question by the end of the video. Here's a reminder of how your notes should be set up to take notes from this video. Okay, I'd like to warn you ahead of time that these notes have a lot of writing, more than you're used to, but it's okay because you can pause this video to write down, and then when you're ready to pay attention, to give your full attention, go ahead and play the video. To begin our lesson, we're going to be solving system of equations, and you can solve a system of equations using different methods. The idea is to determine which method is easiest for that particular problem. So these notes are going to show you how to solve the system algebraically using substitution. Now we already have notes on how to solve a system by graphing, but this is our second method, which is going to be substitution. Here are the steps to solve a system of equations by substitution. And there are 5 simple steps you can use to solve a system by substitution. Go ahead and pause the video, write down all these steps, include the right-hand column here as well, and I'm gonna explain each step through 2 examples. For our first example, we're going to solve the system using substitution, and here is our system here. Remember, system consists of 2 equations with 2 variables. I'm going to go ahead and solve this example, going and explaining each step along the way. Step 1 says solve an equation for one variable. And already that's done for us. The second equation is solved for a variable y right here. So step 1 is already done. Step 2 says substitute. So we need to substitute, which is why it's called the substitution method. We're going to substitute in this y, the second y in the second equation, this y here. We're going to substitute that in for the y in the first equation. Since they're the same y, I can take this 3 plus x and I can substitute that in for this y here. That way the equation only has one variable to solve for. And that's what they explain right here for step 2. Step 3, we're going to solve the equation. Now that I have just x's in this equation here, I can go ahead and solve for x. So I'm going to subtract 3 to both sides, minus 3 to both sides, and then I'll divide both sides by 2, and my final answer is x equals 1. Let's continue our problem by completing step 4 and step 5. On step 4, we're going to plug back in to find the other variable. Since we solved for x on the previous slide, we solved for x and we got x equals 1. Since I have x equals 1, I can plug that in for this x in the first equation or this x in the second equation, and I'll be able to find what the y is. So remember, what I'm looking for is a coordinate point. The coordinate point is my solution. I'm going to plug 1 in for x on the first equation here, and I get 1 plus y equals 5. Then I solve for y, and y is going to equal 4. So now I have 1 for x and 4 for y, and here is my solution. But to make sure that it's correct and that we did our algebra correctly, we need to check to make sure it's the correct solution. Remember, x is 1 and 4 represents y. So I need to plug in the same x here for the first and the y here and make sure that equals 5. So 1 plus 4 does equal 5, and that checks off. And then I need to plug in x here for 1 and y here for 4, and 1 plus 3 equals 4, and that checks off. So the solution is 1, 4. What do you think the answer would be if you graph the 2 equations? Think about that. Remember last week we learned about solving a system by graphing. So what would the answer be if we graph the 2 equations? Make sure you pause this next part and write down the problem. This is a problem for you to check to see if you understand that previous example. Which answer checks correctly? Here we have 1, 2, 3, 4 for our answers. 1 is 2, 2, 2 is 5, 3, 3 is 3, 5, and 4 is 3, negative 5. So which one is going to check out correctly? I want to refresh your memory that each coordinate point represents an x and a y. So for the number 1, I'll show you what to do for number 1, and then you can do 2, 3, and 4 on your own. For number 1, I would plug in for x 2, and for y, I would plug in 2, and make sure that that checks to equal 4. Then for x, for this x here, I would plug in a 2, because remember I have to check it in both equations, the same point. And for the y, I would also plug in a 2, and then I would make sure that this side here is going to equal 2 on the other side, and see if that checks out. If it does, it's my correct answer. So go ahead and check that. Once you've checked 1, you need to check problem number 2, 3, and 4. So go ahead and pause, check the answers, and see what answer you get, because I'm going to show you in just a minute. Okay, I'll assume that you paused the video and you checked problem 1, 2, 3, and 4 in this system of equations. Let's see if 1 was our correct answer. Erase everything. Nope, 1 didn't work. So if you would have plugged in 2 and 2 for x and y in the system of equations, it wouldn't have checked out. Let's check number 2. Nope, number 2 wouldn't have worked either. If you plugged in 5 for x and 3 for y, it wouldn't have checked out in both equations. Let's check number 3. There we go. Number 3 was the correct answer. If you plug in x for 3 and y to be 5, then you would have it check out in both equations. Therefore, the 0.35 is your solution to this system of equations. Here is our second example. We're going to solve the system using substitution. And we have a system, both equations are in standard form. So we're going to have to do step 1. But last example, step 1 was done for us. For step 1, we need to solve an equation for one variable. The easiest one to do that for is the first equation. We're going to solve for the variable x. If I get the variable x alone, then I can substitute in that equation into the second equations for our system. So here are the steps for how to solve for x. We practiced this a lot in chapter 5. You're going to minus 3y to both sides. So now I have x equals negative 3y plus 7. Notice the x is all alone. Now that I have that alone, I can take this entire equation, negative 3y plus 7, and notice how I'm circling the equation, and I can substitute that in for the x in the second equation. So I'm going to take away this x, and I'm going to substitute in negative 3y plus 7. This now completes my second step. And just to go back through, let's review the first step. Step 1 was to solve the equation for one variable. For step 3, in solving this system, I'm going to simplify that equation and solve for the variable y. Here is the work for that. And just a reminder, pause this video and make sure you have this information written down, and then come back to it and follow what I'm doing. Here, you're going to solve for y, and we get y equals 2. And now what I'm going to do is take this y, and I can either substitute it back in to the first equation or the second equation to solve for the unknown variable x. I'm going to go ahead and solve it and plug it in to the second equation for y. And the work to do that is shown here. And now I get my x, which is 1. So now I have my solution, which is 1 for x and 2 for y. Remember, we're always looking for a coordinate point of when these two lines intersect. Our solution was coordinate point 1, 2 for this system of equation. Our final step for step 5 is to check our solution. We always want to make sure this is correct. And this is really important to do on assignments and on your exams. Just a reminder, 1 is x, y is 2. We're going to plug in 1 for every x that we see here. So I'm going to go ahead and just write a 1 on top of that x. And I'm going to plug in a 1 here. And just a reminder that this is multiplying. And then y, I'm going to plug in a 2. So there's a 2 here multiplying and a 2 here multiplying. And I'm going to check to make sure that it equals 7 and it equals 0. We check off here and here. It does. Therefore, the 0.12 is the solution to our system of equation. So here's a question I have for you. When is solving a system by substitution easier to do than graphing? Remember, graphing doesn't always give us an exact solution too. Go ahead and pause the video and try to think of an answer to the question. Okay, I assume that you thought about this question and you paused the video. And I'll go ahead and give you your response. When is solving a system by substitution easier to do than graphing? Well, when only one of the equation has a variable already isolated. When one equation has a variable that's already isolated, like example number 1, it is easier to use substitution than it is to solve by graphing. Here is a final assessment question for you. If you solve the first equation for x, so if we solve this first equation here for the variable x, what would be substituted into the bottom equation? So remember, you want to isolate x here. Go ahead and pause the video, isolate x, and take a minute, try it on your own, and then play the video and I'll have the solution for you. Okay, I hope you tried this on your own. Now I'm going to help you out. If you have 2x plus 4y equals 4, you want to get the x alone so you can substitute it into the second equation. Remember, that's step 1 for solving by substitution. So we need to minus 4y to both sides. And we have 2y equals negative 4y plus 4. And we're going to divide every term by 2. This goes away and I get y equals negative 4 divided by by positive 2 is negative 2y. And 4 divided by 2 is 2, so plus 2. So the equation we're looking for is negative 2y plus 2. Well, here we have negative 2y plus 2 is number 2. So let's go ahead and take away the white box and see if we were correct. I'm going to have to take away the work too to do this. And we got it. It was number 2 was our solution. So we need to solve for x. We get negative 2y plus 2. And we can use this to substitute this entire equation in for x and the second equation.